Hello and welcome to our lesson today. I want us to look at a little bit of revision on further logarithms, and I want to just jump right in, right? And I want to kind of revise what is normally done in Form 2, expressing indices in a logarithm notation. Let's say like express the following indices to log notation. Let's say we have 2 power 3 is equal to 8. Remember, we said that to express this in log form, you just say that the log, and this is the base of the log, 2 of this 8 is equal to that. Alright? Yes, I believe that it can be easier to just know that this one is normally the base of this is the log of this base of this is equal to that. Right? Let's maybe look at another thing. Let's say you have 3 squared. Of course, 3 squared is 9. So in log form, we'll say the log to base 3 of 9 is equal to 2. Right? And we already kind of did this. We just repeating. We did this in Form 2. So let's say another example, 7 to power 2 is equal to 49. Right, if 7 to power 2 is equal to 49, then we can say that the log of, the log to the 7 of 49 is equal to 2. Right? And then also, let us revise a little bit of logarithms to indices. Okay, it's kind of the opposite of what we have just done. Okay, so if you have log to the 7 of 49, right, let's even say they don't give you x, so that you find x first and then you express it in index form. What you're going to do is you're going to say this, the base to this power is supposed to give us 49, right? So we're going to say 7, the base, to power, the power is always the answer, is supposed to give us 49, and we can write 49 in terms of 7, right? We know that 49 is 7 times 7, right? So we are simply going to say that 7 to power x is 7 to power 2, right? It's another way of writing 49. 49 is just 7 to power 2. Therefore, we can drop the bases, and x is what? X is 2. Okay. So, in other words, the log of 7 to 49 is 2. We found x. So in index form, we're going to say 7 to the power of 2 is equal to 49. Okay. Now, let us just remind ourselves using another one. Let's say they say 10 to power 2. Of course, 10 to power 2 is 100. What are we going to say? We're going to say, oh, right. So this one is in index form. And remember, we want it in logarithm so that we make it index. Okay. So this one would have been the log to base 10 of 100 is equal to 2. Right? So the log to base 10 of 100 is equal to 2. Therefore, 10 to the power of 2 is equal to 100. So it's kind of the opposite of each other, right? Let's say they tell you to write this in index form. The log to the base of a half of 4 is equal to -2. Of course, you say a half to the power of -2 is equal to 4, right? So I think that is enough revision on that. That is enough revision on that. Maybe we can also revise something on the laws of logarithms, right? The laws of logarithms. This was also taught in Form 1. The laws of logarithms. So the first law of logarithm is the law for multiplication, and you have to remember that the laws for logarithms are kind of sisters to the laws for indices. They kind of give back. They're kind of sisters, right? So we're going to say that the first law is the law for multiplication, and we're going to say that the log to a certain base of x times y is just the same as the log of x plus the log of y, right? If they say that you find the log of 20 times 10, and by the way, if they don't specify the base, right? If they just give you like, the log of 20 times 10 or the log of 100 or the log of whatever, you have to know that if they don't give you the base, then the base is always to base 10, right? It is always to base 10. Even when you go to the mathematical tables, the four figures, you find that the logarithm that is given there is to base 10. You see, the one that you're even given, the one that you're given in the the mathematical tables, the ones you call for figures, is always to base 10. So you always have to remember that. Okay, let's go back there. So if you're given this, it is just the same as saying log 20 times log 10 can be simplified further to mean it's just the same as log 20 plus log 10, right? Log a times b is the same as log a plus log b, right? Let's say they've given you, say, let's say log of, say, 3 times 7, right? Now, if you look at the table of logs here, you'll find that it goes up to 9.9. Okay, it goes up to 9.9. That is the farthest you can go, right? Past that, it is anti-log. Okay, so it's always very wise to ensure that you have a number that is less than that. You see, if you're supposed to say, if you go ahead and say that this is the log of 14, you may not find it in the tables. But if you simplify this and you say it is the log of 3 plus the log of 7, now the log of 3 is going to be easily found in the mathematical tables. You just go there, and the log of 3 is right here, 0.4771. So 0.4771 plus the log of 7 also can be easily found in the mathematical tables. The log of 7 is right there, 0.8451. So plus 0.8451. And then you can key that in a calculator, 0.5771 plus 0.8451. It should give you 1.3222 as the answer. And someone can decide to test something like, find the log of, say, the log of 18, right? If you go to the mathematical tables, you cannot find the log of 18. But common sense can tell you that the log of 18 is the same as the log of, say, 9 times 2, right? 9 times 2 is 18, which is the same as the log of 9 plus the log of 2, right? If you go very fast to the mathematical tables for the log of 9, there it is. The log of 9 is 0.9542, right? 0.9542 plus the log of 2. The log of 2 and the log of 2 is 0.3010 plus 0.3 3010 0.3010. So you can see that in 0.9542 plus 0.3010, which will give us 1.2552. Right? Another person would have said that the log of 18 is the same as the log of 6 times 3, right? 6 times 3 is also 18, right? So which is the same as the log of 6 plus the log of 3. Let's see if we're getting the same answer. So let's go and look for the log of 6. The log of 6 is right there, 0.7782. So 0.7782 plus the log of 3. The log of 3, 0.4771. 0.4771. Let's add. So we have 0.7782 plus 0.4771. That also gives us 1.2553. Right? You can see the difference is too little. And most of the time they will give you a sign, right? They will tell you to find the log of 18, and then they might give you the log of 6, and then they also give you the log of 3. Now then, you know that you're supposed to use 6 and 3. They might always give you a sign to guide you how you're going to divide that number, right? This was just a general example. Okay, I want us to go to the next law of logarithms. The next law of logarithms states that, so basically the law of multiplication is simple. When you have a log of two things that are multiplying, you can just add their logs. Okay, you can just add their logs. It's as simple as that. The second law is the law of the law of division, that says that the log of x over y is equal to the log of x minus the log of y. Now what you're saying is that if you are finding the log of two numbers dividing, you can just subtract their logs. Okay, yes, like if you're saying what is the log of, say, 8 over 4, the log of 8 over 4 is just the log of 8 minus the log of Such it's as simple as that. It's as simple as that. So that the log of 8, let's check the log of 8. The log of 8, here it is. The log of 8, 0.9031. So 0.9031 minus the log of 4. The log of 4 is right there, 0.6021. 0.6021, let's subtract them. This is 0.9031 minus 0.6021. That gives us 0.301, right? And this would have been found by directly just dividing 8 over 4, and 8 over 4 is 2. So this must be equal to the log of 2. Alright, I'm just using this principle to prove that it's the same. If you look at the log of 2, you'll find it's 0.3010. There it is. Right? So that is it. So if you're dividing, if you're finding the log of numerator and dividing the denominator, it is simply the log of the numerator minus the log of the denominator. Right? This another one is another law, the power law, that states that the log of x to power n is equal to n log x, right? If you are having a log of x raised to a certain power, you can just drop the power back there, okay? Like say if you're looking for the log of 2 to power 2, is the same as 2 log 2, right? Right? So log 2, we know it is 0 0.31 and 3010. So times 2. I think we have looked for this many times. It should be at your fingertips right now. 2.0.3010. So that will be 0.602, right? But we know 2 power 2 is 4. So we can check if log 4 is the same, just to prove that this principle is correct. Okay, log 4 should be 0.6020. Let's check. Log 4, there it is, 0.6021. Okay, so it's kind of almost the same thing. All right, let us now move to something that is a little bit more complicated, so that we apply the laws of logarithms. So let's consider this as our example 1, right? Let's say simplify the following. Say log 125 over log 5. And before we go to that, there's a principle that I would like us to know, that if you have a log towards a base and you're looking for the log of a and the base is the same, the answer is always 1, right? For example, if you're talking about the log to base 10 of 10, like I said in our calculator, all the logs are to base 10. So if you just take your calculator and press log 10, you'll find that log 10 is 1, because the base is 10 and you find the log of 10, so the answer is 1. The log of 7 to 7 is 1, right? So if I want to write, say, 8 in log form, I'll just say, if I want to write 1 in log form, I could write it as log 8, right? I could write it as log, 7. It's all 1, okay? It's all 1. It's all 1. So that is something that you can note somewhere. You can call it uh, not really a law, but kind of a principle. So just call it a fourth. Okay. So let's very fast look at a couple of examples. As I've said, this is going to be our first example. All right. Now, if I look at this, I can see that the denominator is log 5, right? So if I find a way of writing the numerator as log 5, then I can easily cancel the log 5s, okay? Now, 125 uh, can be written as 5 to power something. It can be written in index form. So let's get the factors of 125. 5 goes there 3. So 125 is also 5 to power 3, right? So I can write it as log of 5 to power 3. 5 to power 3 is 125, and then divided by log 5, okay? Then I can use the third law of logarithms. I drop the power there, so that I have 3 log 5 over log 5, right? And the log 5 can cancel, so that we remain with 3, okay? Okay, let us also solve this one. Let's call it b. Log to the base of a squared plus log to the base of a root a. Now root a is just the same as a to power half. We've learned this in Form 1. If you have a problem with this, there is a topic that we have covered there. There's a video that I've made for indices. You can check it out so that you understand indices more. Alright, so the square root of a is just the same as a to power half. Alright, our target is to ensure that we have common things, okay? So that if we drop this one down there, we're going to have 2 log to base a of a plus, this one is going to be log to base a. Let me just go ahead and say to power half, right? Because I've said the square root is the same as a to power half. And then we are going to also drop the half down there, so that we have 2 log to base a of a plus a half log to base a of a. Alright, and as I said, if you have a log to base a of a, then the answer must be 1. Right, I've said that. I don't know if I can find it up here. If I can find it up here, yes, I remembered. I erased it. I erased that. But we can use this opportunity to talk about it again. You see, a log to this base to the same, a log of this number to the same base is equal to 1. I gave an example of a log to base 10 of 10. I said it's equal to 1, okay? So this one is going to be 1 and this one is going to be 1. So we are going to be left with 2 times 1 plus a half times 1. So the answer is going to be 2 and a half. Alright, let's have another one. Let's call it 6. The log of a squared plus the log of b squared minus the log of ab. So you notice the moment you have the the, the, the laws of logarithms at your fingertips, it just becomes easy to just solve them. You see, the moment I see uh, the powers there, you want to drop them, or maybe if they are not dropped, if they are behind the log, you want to bring them up, So the moment I see log AB here, the moment I see log AB here, I know log AB must be equal to log A plus log B, right? So I'm just going to rewrite this equation and replacing log AB with log A plus log B, so that we have log A squared. I'll write this a little bit well. So we have log A squared plus log B squared minus, alright, I'm putting that bracket because I want to just write this, I'm leaving the minus outside, so that one is log A plus log B, and then this negative is going to affect everything inside the bracket, so that we have log A squared plus log B squared minus log A plus log B, alright. And of course, as I said, you might want to drop this and then collect the like terms. So 2 log A, and then I'm going to bring this one now, minus log A, then this one will be 2 plus 2 log B, I'll drop the power, then plus 2 log B, and then plus log B, right? Now this is like 2a minus a, that one is going to leave us with a, so 2 log a minus log a is going to leave us with 1 log a, and then 2 log b, there's a mistake, there's a little bit of a mistake here, right, there's a little bit of a mistake here, you have to be very careful with the sign. Remember, this sign was outside, so it affects everything. When you open the bracket, it affects everything. This one is log A, this one becomes negative log A, and then negative times positive also leaves us with negative log B. Alright, so this one is going to be log A, and then also 2 log B minus log B is going to be plus log B. Alright, let us have another example. I'm going to call it example 2. This is going to be the part A. We're told to say to evaluate the log to base 5 of 14 is equal to x, right? So if you're supposed to find x here, you're going to first write it in index form. Huh? Step 1, write in index, so that you'll have 5 to power x is equal to 14. And then step 2, we're going to introduce log to base 10, right, to both sides, so that we have log 5 power x is equal to log 14, right? So that's x log 5, we're dropping the x, will be equal to log 14, right? So x will be log 14 over log 5, alright, 14 over log 5. And remember, as I said, this one cannot be read directly from the books of, from the tables, but you can make it readable. You can say that log 14 is just the same as log 7 times 2, right? Which is just the same as log 7 plus log 2 over log 5. So that we go and read that now from the tables. So I think log 2 is 0.3010. Log 7 and 5 you'll have to check. So I start with log 5, it's closer, 0.6990. Alright, 0.6990. I'm very sorry about that. So where were we? So we had the question, and the question was simple. We were supposed to evaluate the log to base 5, 14 is x. So you say that 5 to the base, to power x is 14. Now we are kind of writing it in index form, and then we introduce log to base 10, right, on both sides, right, so that we have log to base 10 of 5x is equal to log of 14. So divide both sides by log 5 so that we have x is log 14 over log 5, and then 14 is just the same as 7 times 2, which is the same as log 7 plus log 2 over log 5, and then we have read this and that from the tables, so that our answer is going to be 0.8451 plus 0.3010 divided by 0.6990, so that our answer let me just do it again, 0.8451 plus 0.3010 divided by 0.6990. The answer is 1.6396. Alright, let us also try and evaluate log to base 6 of 28. Right, so we are going to just equate it to, let's use y for a change. Right, let's use y. So we're going to say 6 to the power of y is the same as 28. And then we're going to introduce the logs on both sides. Then we drop the y, so that y log 6 is equal to log 28 over log 6 over log 6, so that we have y is equal to log 28 over log 6. Now log 28 cannot really be read from the table, so we can say it is log 28. 28 could be 7 times 4, right? Log 7 times 4 over log 6, which is just log 7 plus log 4, using the law of multiplication, over log 6. Alright, so log 7 is, you already know how to read this from the tables. So log 7 is 0.8451 plus log 4 is 0.6021, right, over log 6 is 0.7782. Right, let's just check. Log 7, 0.8451, there it is. Log 4 and log 6. Log 6 is closer. Log 6 is 0.7782, there it is. Log 6 is 7782, and then log 4. Log 4, there it is, 0.6021. So let's see the answer. 0.8451 plus 0.6021 divided by 0.7782. The answer becomes 1.8597. Right? So you can look at another example. Now let's say you have 5 to the power x and 5 to the power x minus 1 is equal to 10. We're going to start first by using the law of indices. We are dividing indices of the same base, so we can easily combine them. And this is the law that we're going to use. A power b times a power c. The base is the same, so you just add the powers, right? So 5 to the power x plus x minus 1 is equal to 10. So this one is going to be 5 to the power 2x minus 1 is equal to 10, right? And of course, the next step remains the same. We introduce the logs on both sides, okay? And then we drop the powers. So 2x minus 1 log 5 is equal to log 10. Alright, so that now we have 2x minus 1 being equal to log 10 over log 5. Alright. So log 10, remember, is 1, right? Because as we said, when you have a log and you're not given the base, then the base is automatically 10, right? So that one is 1. So we have 2x minus 1 being equal to log 10 to base 10, that is 1, over log 5, and log 5 is 0.6990. So let's just put it in 0.6990. Alright, and so we can get that, and then we bring the one the other side. So 2x is 1 over 0.6990, and then plus 1, so that we have 2.4306 divided by 2 divided by 2, x becomes 1.2153. Alright, remember, you can always pause the video and try to solve the problem before checking whether you got the answer correct. Alright, so as I'm writing this other problem, you can feel free to pause the video a little bit so that you look at it and then you do it later. Already it's in index form, so we're just going to introduce the logs. 2x plus 1 is equal to the log of 3 power x, so that we drop the powers. X plus 1 log 3 is equal to x log 3, right? And you can divide both sides by log 2, So that we have x plus 1 is equal to x log 3 over log 2. Can again divide both sides by x, so that we have x plus 1 over x is equal to log 3 over log 2, right? So x plus 1 over x is equal to log 3. We know log 2 is 0.3010. What is log 3? Log 3 is 0.4771. 0.4771. So x plus 1 over x is equal to 0.4771 divided by 0.3010. That is going to give us 1.5850. Let's cross multiply. So 1.5850x is x plus 1. So you can check the x there. So this will be 1.5850 minus x. I believe that is going to give us 0.5850x is equal to 1. So divide by 0.5850, 0.5850. So 1 divided by 0.5850 is going to leave us with x being 1.7094. Right? Doing good. Doing good. Now just to do another problem. And this one is going to be a little bit more complicated. Solve the simultaneous equation. So we have log to this xy is 2, and then we have xy is 8. We have two simultaneous equations here. How are you going to solve this? If we look at the first equation, we can write it in index form, and can say that x to the power of 2 is y. So x squared is y, equation 1. Xy is 8, equation 2, right? And we just solve these two equations using substitution method, okay? We already have y, so we can just put y there, so that we have 8x and y is x squared, so x squared is equal to 8. We are substituting y in equation 2, right? So the law of indices states that this one will be x to power 1 and then plus 2, that is x to power 3. So x to power 3 is 8 cube root, therefore x is 2, and y is x squared, so y is 2 squared, therefore y is 4. So x is 2, y is equal to 4. I hope you found that one. Let us look at another one. Feel free to pause the video and try solving it yourself, so that you see if you're doing good. So we have log x plus y is equal to 0, and then 2 log x is equal to log y plus 1. So pause the video, try to do it, alright, so that you mark for yourself later. So what I'm going to do is I'm going to deal with the first equation first, okay? Alright, remember we are given log x plus y is 0. That means it's also it's obviously at the base of 10. So 10 to power 0 is x plus y. Alright, now I'm writing it in index form. 10 to this power is that, and anything to power 0 is 1. That means x plus y is equal to what? To 1. Okay, that is our first equation. And then look at the second problem. We have, the second equation. We can also deal with that. So that we have 2 log x is equal to log y plus 1. We can take this one there, so that we have log x squared is equal to log y plus 1, right? You can see that the logs can now be dropped. Okay, so I want to write our two simultaneous equations here. We have x plus 1 plus y is 1, and then we have x squared is equal to y plus 1, and this can be solved simultaneously. And maybe we can use the first equation. We say make x the subject or y the subject, right? Let's make y the subject in equation 1. So y will be equal to 1 minus x, all right? Substitute in equation 2. So that equation 2 says x squared is equal to y, and our y is 1 minus x plus 1, all right? All right, so 1 plus 1 is 2. So if we take everything to one side so that we solve it, we're going to have x squared and then plus x, and then 1 plus 1, that is plus x plus x. We just have this real fast. So x squared plus x is equal to 2. So x squared plus x, and then minus 2 is equal to 0. Sorry about that. So we solve this equation. Maybe let's use the product method. The product here is going to be negative 2. The sum here is going to be 1. All right, so the two numbers are going to be 2 and negative 1. Negative 2, 2 times negative 1 is negative 2, and then 2 plus negative 1 is 1. So we are going to have x squared plus 2x minus 2 is 0, so that we can have x common here. So we have x plus 2, and then negative 1, so that we have x plus 2 being equal to 0, right? So x minus 1, then x plus 2 is 0. So x is 1 and x is negative 2, right? But now, for log to be defined here, our x must be greater than 0, right? For log to be defined, our x must be greater than 0. So we're going to use x is 1, right? If you try finding the log of a negative number, it will tell you math error. So there is always an error if the log of something is negative. So we're going to use x is equal to 1. And therefore, when x is 1, what is y? X plus y is 1. X plus y is 1. So x plus y is 1 and x is 1. So y is going to be equal to 1 minus 1. Y is going to be equal to 1 minus 1. So y will be equal to 0. All right. Now let us look at a few more examples. Let's look at a few more examples. Solve the following. Solve the following. And you're supposed to solve log x is equal to 4 log 2, right? Just a minute and sort out an issue with the pen. So log x is equal to 4 log 2. Okay, so you obviously take that from there because we might need to drop the logs so that we have log x being equal to log 2 power 4. Alright, now at that particular juncture you can drop the logs so that x is 2 power 4 and then x is 2 power 4, therefore x is 16. Alright, you can look at another one where we are told that 1 plus log to base 5 of x is equal to log to base 5 of 12. And of course, we are supposed to find the value of x. So we're going to first write this one in terms of logarithms. Remember, we want to combine them so that we have log something on the left hand side, log something on the right hand side, and then you cancel the logs and you find the value of x. You must always know what you're targeting. So 1 can also be written as log 5, log to base 5 of 5. It's just the same as 1, right? So I'm going to rewrite that and say it is log to base 5 of 5 plus log to base 5 of x is equal to log to base 5 of 12. going to combine these two so that we have log to base 5 of 5 times x. Remember, log of this plus log of this, and the bases are the same. It's just like the log of this times this. That's what I'm doing. All right, 5 times x is 5x. Is equal to the log of to base 5 of 12. So the logs can be dropped so that we have 5x is equal to 12, and therefore x becomes 12 over 5. Right? Let us finally have our last example for today. Last example for today is going to be simple. We're going to change the color to blue. It's going to be log 3x plus 4 minus log 3 minus x is equal to 1, right? So as usual, we want to make sure that we have one log on the left hand side and one log on the right hand side so that we can drop them, okay? So we have to write 1 in terms of log, and we know the moment we are not given the base, then it must be to the base 10, right? Must be to base 10. So we are going to say that this one will be log of 3x plus 4 over 3 minus x is equal to the log 10, right? Here we are using the second law of logarithms that says that the log of a minus the log of b is just the log of a over b, right? And then because we know that these logs are the base 10, then we can write 1 as log to base 10 of 10, okay? Then we can drop the logs, right? So that we have 3x plus 4 over 3 minus x is 10. Cos over 1 equals multiply. So that 3x plus 4 is 10 times 3 minus x. So that we have 3x plus 4 being equal to 30 minus 10x. Okay, so that we collect the like terms, and we take the 10 here, so that it is 3x plus 10x is equal to 30 minus 4, right? So 3 plus 10 is 13x is equal to 30 minus 4 is 26, so that we have over 13 over 13, x becomes 26 over 13, and therefore x becomes 2, right? If you have reached this point of the video, I believe that you've benefited a lot. I believe that you've learned a lot, and that is always has been my wish, that you understand the topic, right? If you have a problem maybe with a question that is concerning the same topic, you can always leave the question in the comment section, or you can also find me using this number so that you raise your concern, right? Enjoy your time and follow us for the next video. Bye.